or you have an extraneous solution. But a lot of this is just working backwards. I've got about 8 examples, 9 I think, and we'll go from there. It shouldn't take us all day to go through this. So, excuse me. Of course, unfortunately, I have to rewrite a lot of this because it doesn't look good. So e to the negative x squared equals e to the negative 3x minus 4. How do you solve that? What do you do? Right. You set them equal to each other. Because how do you undo an e? So you can natural log both sides, the exponents drop. Or you'll notice, since these have the same base, the exponents have to be equal. Which means you have 4 and negative 1 through the zeros. And then it's just a matter of substituting in to double check to see if they both work, or if one of them works, or you have what's called an extraneous solution. Sometimes when you have multiple values that work, one of them will work, both of them will work, only one of them will work, neither one of them will work. So you always just take a quick second, excuse me, and see what works. Okay. That was not fun. What about the other one? We have 3 times 2 to the x equals 42. Almost. Not yet, though. Divided by 3 first. Okay. The reason you have to divide it by 3 first is because you have this, before you get to your powers of 2, that's where you're headed at, is you want to get this to the other side. So once you have 2 to the x equals, what would that be? 14. Can I rewrite 14 as a base 2? No. So, how do you get an exponent to drop? You use log base 2 in this case. So in this case here, you'd have to take the log base 2 of both sides. So x would equal the log base 2 of 14. Now, in your calculators, if you want to get to the log base, as soon as you hit log on yours, it's going to ask you for the base. Looks like just cut it. These things take forever to load. Once you hit Control 10 to the X, it automatically pops out where it wants you to type in the base. So you just write 2, arrow over. It didn't work. And there's your answer, 3.81. From what I was reading when I was setting this stuff up for today, the book usually goes 3 decimal places. So if you want to keep it standard what the book is doing, that'd be fine. So if you went 3 places, you go 807. Okay. I'll tell you. Round it to the nearest thousandth or the nearest hundredth. Usually, from what I've read, the book usually goes 3 decimal places. Or I might say leave it in the exact form. If I say leave it in the exact form, your answer would be log base 214, or 2 of 14. Excuse me. Okay. Yeah. Then then you wouldn't need a calculator, would you? E to the x plus 5 is 60. What do you do first? Good. So Subtract 5 from both sides, so we get e to the x is 55. Very good. Here you would take log base e of both sides, but log base e is? Natural. So once you natural log both sides, you get x equals the natural log of 55. Which means you have to hit a button. Calculator. I can't drive it. I can't drive 55, standard day car. You have one foot on the brake and one on the gas.
What would happen if you did that?
pass.
If you put one foot on the brake and one on the gas?
Torque brake. Try it.
I will tonight.
Don't try it. Don't do it. No, don't.
I'm
Don't.
38, I'll
No.
try it.
Don't.
Wait, actually, what?
Depends on how your engine will rev and you'll want to move forward. If you have rear-wheel drive cars, sometimes the back end breaks out and it starts spinning your tires.
Oh, like
That's my
Is your Jeep at least a 5-speed? It's probably a four-cylinder automatic. It's not even a Jeep.
Still a Jeep. It says Jeep.
I got a.
It's got power wheels.
It's so fake. It's great value.
My kid's power wheel had more torque than that thing.
Mr. Murphy, it's great value.
Yep.
It's off, right?
It's a Suzuki Samurai.
Need to add 4 and divide by 2.
Yeah. Obviously, in this case here, excuse me,
Divided by 2 is 7.5.
you're going to start working your way backwards again. So you have 2 times the quantity, 3 to the 2x minus 5. All subtract 4 is 11. Work your way backwards like you would any other equation. Just how you undo exponents, we have to take logs. So you have 2, 3 to 2x minus 5. And you're probably right. If you wind up with 7.5, it'd be quicker to type into the calculator than it would be 15 over 2. It's not a big deal. You're going to have to use the calculator. But how do I get the exponent to drop? It's log base 3. Okay. So I wind up with 2x minus 5 is going to equal the log base 3 of 7.5. Now, everybody agrees you're going to have to add 7 and divide by 2, right? At this point. What you have to do here is you have to type that in your calculator first. So x is going to wind up equaling log base 3 of 7.5 plus 5 divided by 2. So we have log base 3
Wait, can you just type
Yeah, as long as you get out, once you get out of the parentheses, it was plus 5, then hit enter, and then divide it by 2. I mean, if you wanted to put it as one giant fraction in there, you can do that as well by hitting the fraction bar. It'll do the same thing. It works just as well. It's just pressing buttons. You guys should be very happy with this stuff. What's that? I said Navy Peter.
Let me teach. Great.
Uh-oh. You might want to rewrite that so you can read it.
I know.
Your handwriting is terrible.
Wow, it's really cold up here.
Boo!
Why is it a minus?
You don't match!
Your clothes aren't matching. I was just about to say that. Dang it.
Why are you wearing that?
Gray doesn't go with black.
Do you like moose better? Yeah, I was just going to say that.
That was my next one.
Is that a Z?
Okay, so you
Remember
move
last year?
the two. You move the two to the other side.
No, you don't.
So, Chandler.
Oh, I failed that one.
Caleb. Okay.
What?
Oh.
Negative.
Okay.
Some.
So then
You better take the reins.
Step in.
you
Substitute.
No, that's
log base each of them by e to bring their exponents. No, natural log. Yep. You natural log each of them to bring the bases
What do you do
down.
with the 3?
So
What about the 3? What do you do with that?
okay, relax. You divide. No, you divide them by 3. Most likely.
What?
I want to use that.
No, you do the natural log. So you natural log.
There's not even a Z up there. Oh yeah, this is Z.
You got negative.
I kind of, it was perfect that you said that right then, because it kind of set you up. This is the type of problem, let me rewrite this here.
You guys all are vulnerable. I believe in that.
Thanks, Sydney. It means a lot. Sydney said she believed in me.
Incorrect.
Excuse me. So, at this point here, there's 2 ways of going about this. You may or may not recognize, since we didn't do a ton of this stuff before. This is the same thing as writing it as e to the x. Which means you could factor this.
Oh my.
Here's what I can do. Do you remember this little trick before called U substitution? No. It's a nice trick when you see 3 terms, when you have your powers descending like that, like a regular old quadratic. What you can do is this. U squared minus 3u plus 2. What times what's 2? You add together to get negative 3. Yeah, negative 2, negative 1. So you can factor that to be u minus 2 and u minus 1. You okay with that? But what did I let u equal? E to the x. So you wind up with that.
Why can't we just say X?
Because there's an x in the
I
problem.
like what
It's,
you substitutions.
and that's the other thing. It's called U substitution. It's because you're letting, you can call it D substitution or F substitution, whatever. It's just the way that most books call it as you get on, they usually call it U substitution. We're getting there. So when you get to this part, remember, these are both still set equal to 0. So you're going to have e to the x has to equal 2, and e to the x has to equal 1. Notice what I did there is I set them both equal to 0, and I just moved the constants over. Are we okay with that?
So like, X.
Well, you just natural log it and see, what would it, yes, you're right. What would this one have to be? Because this one has to be 0. And then here I take the natural log, so x would have to equal the natural log of 2. So my 2 answers here would be the natural log of 2 or 0. That's one way of going about it. The other way is that you could use the calculator. If you go into your function to graph it, if you graph it, it's just looking for a 0, isn't it? You can calculate 0 on that calculator. So if you have a calculator and it's a calculator portion and you're trying to find a 0, obviously you could use the little U substitution trick. Excuse me. Or put it in the calculator in y equals table, or not the table, excuse me, but if you go back and hit your analyze button, it'll help you find it as well. So I kind of set you up on that one, Maddie. It's perfect timing.
I know. I'm sure you all enjoy
Yeah.
me.
Okay. I don't know what the natural log of 2 is. It's probably some decimal. Okay. Natural log of x is 3. So how do you undo a natural log? You e it. So x would equal e to the third, which there's a button. So find e.
Don't worry.
E.
20.
20.086. How did I do that? The E button?
It's right. What do you want?
Read the instructions. She was asked that earlier. I think the book usually goes 3 decimal places. So it'll say 1,000 or, I mean, last year I usually went 2, but if this one goes 3, I'll go 3. Excuse me. Yes, sir. Yeah.
No.
Is the log equal?
What?
I could have done this.
She said with a snotty voice. I could have done this.
What?
I could have done all of
What do you have to do? Remember how you get rid of the log 3s? Remember, yeah. No, it's Maddie's right. What you do is we call it exponentiating. You put, since this is a base 3, I now make this a base of an exponent. So it's 3 to the log base 3, so that you have 2 different bases that are the same. That's how these things drop. Or noticing that you have the same log base on both sides, they have to be equal, otherwise it doesn't work. But the correct way of doing it, I think that's what you're saying by putting a 3 there. The 3 becomes its own base, the log goes up as an exponent. That's how you get the same bases for it to drop. And you're right, we called it exponentiating. I don't know if that's the right term or not. So. X is 2. What number are we on, Maddie?
that was the 7.
You do this one.
Ready.
Sure.
All right.
I thought you don't like going.
Okay.
Sit down.
I got this, guys. Don't worry.
Are you going to rewrite? Thank
Yeah.
you.
Okay. Well. You know what?
Is that a 6?
Yeah.
Why is there a T?
Is that a plus or a T?
Okay. You know
Is it an
what?
S or a 5?
So you exponentiate and
Wrong answer.
no. No, listen to me here. You exponentiate all of them,
No.
so then you get
No.
3x plus
No.
14.
No.
You just said no. It's wrong.
When you have subtraction of logs, what does that mean?
Division. You have to condense it. That's the right word, right? Okay.
Yeah, guys, at this point here, and again, I may or may not have set her up on this one.
He did.
I did, yes.
100%.
So no, you get 3x plus 14 over 5 equals 2x.
That's where you go with this one.
All right. So then, figure it out. You multiply. You cross multiply in 5, right? Yep.
No,
Look
what?
at our
5 by
students.
5. Multiply.
Oh, right. Okay, so 5, and then 5. So
What teacher got this?
Now my class. I'm teaching Clay.
Oh, it's
Clay, guys, last year I asked Clay to prom for this year and he said no. So there's that.
Clay. Where's
Oh,
Wait, time out.
Hey, Clay.
This year, I didn't say no. Like last year.
Yeah.
Clay, get out of here.
What'd you
Clay,
say?
get out of here.
Don't tell them to leave.
She wants to go
Okay,
to prom with
so
you.
you get
Take her to
3x
prom.
plus 14 equals 10x, and then you move the 10x over there. Well, you
Why would
move
you
the
do
3
that?
over there because that's easier. So then you get 14 equals 7x
Your handwriting's awful.
divided by 7, x equals 2. That's the answer.
What is it?
So yeah.
I don't like math anymore.
Watch out for those walls, they jump out at you. Eventually, we got to the right spot. What I want you guys to see here is sometimes they will set it up where you have to condense the log before you can solve it. So when you condense logs, remember subtraction means you're dividing them. So if you rewrote it as 3x plus 14 over 5, get rid of the divide by 5, so you multiply both sides by 5, and then it winds up being real fast. Okay?
What would you do if you actually like or like spitball?
Alright. 5 plus 2 natural log of x is 4. Excuse me.
Do they come to flex for you because they don't like their teacher?
No. Sometimes other teachers get busy, and sometimes I'm not that busy. Absolutely, yeah. What do you do first? Subtract 5, good. So we have 2 natural log of x is -1. Natural log of x is -1/2. How do you undo natural log? You e it, so it becomes e. So x equals e to the -1/2. Log base e. Natural log. Well, I'm sorry. E is an approximation as n gets large as 1 plus 1 over n. As n gets larger and larger and larger, it's approximating to some decimal. The decimal is e. They call it that. It's like pi.
Okay, that's fine.
So x is some number. Was it point something or another?
0.667.
Okay. Again, you are just walking backwards through solving an equation. Hopefully it's not very difficult.
Good.
9 or 10, I don't remember.
You said 8 or 9.
There may be like
Counting is very difficult.
Yeah.
2, well, 5, 3x. Oh my goodness.
So the first thing you got to worry about here, you got to move the 2. Okay. How do you move the 2? So we have log base 5. And then what? 5 it. Right? Pretty much, yeah.
Yes.
So you 5 it.
You natural log, why don't you just 5 it? So, you feel wrong, I know.
25 over 3. I do believe this might be the last one that I have then.
Dun, dun, dun.
Yeah, because this is kind of.
Oh, here
What?
it goes. Oh, wait.
5 squared. I had exponentiated, I put 5 to the log base 5, that way it drops down. Does this become?
Said, guy who,
A lot of times I'll say stuff and I just write it down.
Baseball player.
So last one, and I left this one to show you guys as extraneous solution. A lot of times when you get these problems, you do wind up with things you have to check. And it's usually when you have 2 separate values for x. Now, Maddie might recognize what you'd have to do first.
No, I'm just, I
No, what do you think I gotta do first?
Oh, you actually, because they're
multiply
both
it.
log base 10.
Gotta multiply. Because of the addition sign.
Oh.
So you gotta condense it, okay? As soon as you start to see you have multiple logs,
That's really confusing.
well, whenever you see 2 logs combined with addition or 2 logs with subtraction, when you're solving, you have to condense it first before you do it.
It makes me think though that experiment and.
I gotcha. So this is the same as log of 5x times x minus 1 is 2. Okay. How do you undo log? You 10 it.
Yeah, you do tend to, don't you?
Because the base that you don't see is a 10. So you 10 to the log base 5x times x minus 1 has to equal
Oh, I have
1.
I
Yeah,
don't know, you probably already said it. You won't distribute 5x.
I'm not there yet.
Oh, my fault.
That's okay. I'm not there yet. Because now I have 5x times x minus 1 has to equal 100. And now I'm at the point where I have to back.
Oh,
Okay.
so you do distribute?
Now you will.
Okay, I don't know. Yeah, I'm going to like, my inside like 5 or something.
One thing you could do here to make your life easier is what's the first rule of factors?
Greatest number.
What can I take out?
Take out 5.
Since I have it equal to 0, will that 5 add any bearing on the problem?
No.
No. So you have x squared minus x minus 20. What times what's negative 20? You add together to get negative 1.
Negative 5 and 4.
Negative 5 and 4. Very good. Okay. So I have possible zeros then at 5 and negative 4, but I need to check them. Okay. Can I take the log of a negative number?
No, that wouldn't be
Well, press the button, see what happens.
good. Hey, Jack, press the button.
I'm gonna go out on the limb and say it's not gonna work.
Not real calculation.
Is that what it says?
I can't tell what to do.
Yeah. You're gonna throw out the negative 4 because that's what you would call an extraneous solution. It's a solution, but it's not a solution.
That blew my mind.
The negative 4 in this case won't work. Sometimes the negative value might work, sometimes the negative won't. This is why you gotta double check your 2 boxes. That's really good. I think I've done one of every type of examples we can get. All right, I knew it wasn't much. I know you guys have all seen these before. The only one that I know you'll probably get a little goofy on is when you have to do that little trick of the use substitution when trying to do a little bit of factoring. But other than that, it should be pretty good to go. Yeah. Yeah, I'm gonna do that here. Day 1 stuff. I got day 1, day 2. So if you want to work on either one, because like I said, I won't be around tomorrow because we got the math team meet. So what is that?
Exactly what he said.
We have the whole conference. The conference. There's what 12, 13 schools or something in the conference.
Yeah.
We all go to Caneland has their old middle school next to their high school. They don't use the building anymore, and it's kind of like
Wait, did
So you guys just do math problems?
yeah. You have 20 minutes to do 4 questions in a specific type of level, if you will.
It's probably like the AP test, isn't it?
No.
Oh, it's not. It's like they do
No,
like
there's specific levels of classes, like freshmen can only take certain tests, sophomores and so on. And there's 4 questions on each one of the tests, and they get progressively harder. You get 1 through 4 possible points, so that's how the things are scored. And they keep 4 people go take, in each school, 4 people go take a test. They take top 3 scores if you get your points. So last year we placed 4th, I think, in conference.
Is that good?
Yeah, it's really good.
Out of how many teams?
The 12 we were
Oh,
doing, so
Oh,
we did really well. So
Oh,
it's not like somebody threw up and put 15 points or scored 7 touchdowns.
How many people are on?
They got about 35 or so of us. We don't really need to have that many of them to fill in all. Let me write this down and I'll show you. So day 1, I forgot what page this was.
253.
Thank you.
just wait for it.
That'd be a good idea.
I changed it.
It's every 4. Are there people on the You never heard of the weighted test?
Yeah, I did just in case you, I mean, it seems like it's a lot. The thing, if you're going 24, 28, 32, 36, 40, it goes by real fast. Every 4th. Go by 4. So it's 24 plus 4. Plus 4. So, I think there might be 20 of them, but it, anyway, there's about 20 or so of them, but as you can see, the problems themselves go by real fast. There's really not a lot of good in this here. Okay? So,
We can work on those. That's
tomorrow, Wednesday, I don't know what we're doing yet.
Okay, so we
We got this, yeah.
can take it one.
You'll get it.